All right, I gave you 5 points to plot for your warm-up. So remember, on the right side is your positive x values. On the left side is your negative x values. When you go down, those are your negative y values. And when you go up, those are your positive y values. So when you plotted the point 2, 0, is the 2 the x or a y? It's an x. Is it positive or negative? Positive. So we're going to go from the origin. We're going to go positive 2. Does it go up or down? No, this one has 0, right? It didn't go anywhere. So here's our point A. All right, point B. How am I going to get there from the origin? Starting at the origin. Left 2 and then down 4. 1, 2, 3, 4. Here's our point B. So this negative 2 was left. This minus 4 showed me down. All right, how about point C? 3, 2. I think you had it right the first time. 3 to the right and then 2 up. So our x is positive, we go to the right. Our y is positive, we go up. All right, how about the point 4, negative 2? 4 to the right and 2 down this time. 1, 2, 3, 4, down 2. There we go, there's our point D. And then the last one, point F, to have negative 1 for your x and positive 3 for your y. How are we going to move? Left 1, good. And then 3 up. So left and then 1, 2, 3. Good. Nice. How we do on plotting points? Are we feeling better about it? We're going to keep practicing because that is something that y'all struggle with in Algebra 1. We're going to keep practicing it because it's really, really important. Okay? Today, we're going to look at very specific points. We're going to look at the intercepts. Okay? So an intercept of the graph is where it intersects one of our axes. Okay? We have an x-axis and we have a y-axis. So if it's sitting on the axis, that's an intercept. Okay? An x-intercept is when you're on the x-axis, and a y-intercept is when you're on the y-axis. Okay? So did I plot any intercepts when I plotted them in my warm-up? Are any of those sitting on an axis? So let me show you what I'm talking about. Like this is the y-axis, and this is the x-axis. Did anything get plotted on one of those? Yeah, point A got plotted on which axis? The x-axis, so it's an x-intercept. Okay, so in our warm-up, point A was an x-intercept. So we're going to look at those today. We're also going to look at where my function is positive and where my function is negative. So when we're talking about positive versus negative, we're looking at when my output is a positive number or a negative number. And output is my y values. Okay, so to have a positive, it's when it's above the x-axis. So that's when we have positive y values. So like points C and E are in the positive, right? They're above. So in this case, C and E are positive points. And then to be negative is when we're under the x-axis. So this is when we're going to have negative y values. So in my warm-up, that is point B and D. How come I didn't put A in either of those lists? Is A above or below the x-axis? No, it's on it, right? So it's special. So it's technically at a y value of 0. 0 is not a positive or a negative number. It's neutral. It's in the middle. So our warm-up had points. We're going to do the same thing, but with like a whole graph. So we're not going to have just certain pieces. We're like, hey, everything to the right is doing this. Everything to the left is doing this. Okay? So when I'm referring left to right, remember, we're looking at x values. Okay? To the right of this is when my y's are above. To the left of this is when my y's are below. Okay? So when we refer to the sides, we're using x values to say that. Ready to do some? Yeah? Okay. Here we go. So my first one is a line. Okay. Do I have an x-intercept? Does this line cross the x-axis? Yes. Where is that happening? Looks like it's at 3. Good. So an x-intercept is when x equals 3. Do we have a y-intercept? Yes. Where is this happening? What is that? 1, 2, 3, 4, 5, 6. When y equals 6. So for right now, you can just say 3 and 6. Later, they might make you write the whole point. But for today, we're going to leave it like that. If I wanted you to write the point, this would be, 0, 6. This point would be 3, 0. You can. It's good to know. It's going to help you with something in the future. So notice my x-intercept has the x of 3 but a y of 0. That makes sense. It didn't go up or down. Okay? The y-intercept, my y is 6 but my x is still 0. Makes sense because it only went up. It didn't move left or right. We good? All right, so now we're going to look at positives and negatives. Okay? So I'm going to do green for positive. So positive is where my graph is going to be above the x-axis. Whoop, I just erased all of it. Where we're above the x-axis. Okay? So what part of my line is above the x-axis? Okay? It looks like specifically this part of my line until we hit the x-axis. Okay? So where did we hit the x-axis? At 3, right? You with me? Okay, so all of my x's to the left of an x value of 3 is showing where we are positive. So we're going to say when my x's are less than 3. Your arrow actually points to the left. Okay, so we were specifically looking at just this part of the line. So if I have an x of 2, an x of 0, an x of -1, they're all going to have a y value that is positive. Okay. Now looking at when we're negative, that's when we're under the x-axis, so that's the other half. That's happening when my x's are bigger than 3. Do we see that? So x of 4, x of 5, x of 6, their y values are going to be under the x-axis. Okay, so right here, we're going to say we're negative when y's are greater than 3. Okay, so again, we're kind of cutting it in half. I'll give you a visual. Couldn't find them? I'm sorry. So this is the left side. This is the right side. So on the left side, my y values are positive, and on the right side, my y values are negative. Does that make sense? Is that okay? This part can get really confusing, so if you get confused, please tell me. Okay? It happens all the time, every year. Even Algebra 2 gets confused. So, no shame. If you are like, what? Tell me. Okay, we're going to do another line. So I come over here. Do I have an x-intercept over here? Does it cross the x-axis? Yeah, it looks like it's happening right here. What value is that? -2. So we have an x-intercept at -2, which you could also say -2, 0. It's the same thing. Do we have a y-intercept? Yes, where's that happening? Excuse me. 1, 2, 3, 4, 5. Looks like -6. When y is equal to -6. So as a point, that's going to be 0, -6, like that. I'm going to wait. I'm going to ask that question in a minute. Okay. Ready for positive and negative? Yes? So if you are a visual person like me, so do we agree that this is above the x-axis? And then all of this is below the x-axis? So if you need to use highlighters to kind of do that on your paper, do it. Okay? So, because then I can also see that they're split right there at that -2. So we have on this side of -2, and we have on this side of -2. The left side, the right side. Okay? So on the left side, when x is less than -2, on the left side of -2, are we positive or negative? On the left side of -2, yeah. See when my arrow is pointing to the left? So over here, so that's the green piece. Is that positive or negative y values? Positive y values. Good. So we're positive when my x's are less than -2. So if I have an x value of -3, my y is going to be positive, right? Because it keeps going up. Anything over here is going to have a positive y value on the line, right? So that part's figured out. How about over here? When x is greater than -2. So on the right side, these are negative. So our inequality sign is going to point that direction when my x's are greater than -2. So if I have an x of 1, 3, 7, 0 even, we're going to have a y value that's a negative. Okay, now I'm going to ask the question from before. Did the y-intercept help me with positives and negatives? Did the x-intercept help me with positives and negatives? Yes. See how they're the same thing? So on our first example, our x-intercept was 3, and look at that. We used 3 for the positive negative, right? Over here, our x-intercept was -2. That's what we use for positive and negative. Do you think that will always happen? Say yes. Yes. Okay? Your x-intercepts will always help you with positive and negative because that shows that's on the x-axis, and positive and negative is either above or below the x-axis. So above or below that point. Yeah? Because now we're going to put some curves in there. We got to make it more like Miss Douglas. You can laugh. Whatever. I'm proud of my curves. Worked hard on these. Lots of donuts. Y'all can laugh. It's okay. There we go. There we go. Some kind of giggle. Y'all are so asleep in this class. Okay. Our third one, it has a curve. It's a parabola. Okay. Do I have x-intercepts? Does it cross the x-axis? Yes. Where does it happen? It happens at 3 and -4. So this one has 2 of them. Okay. So we have x-intercepts when x equals -4 and 3. There's 2 of them. So it's -4, 0, and 3, 0 are the 2 points where we're crossing over the x-axis. Do I have a y-intercept? Yeah? I don't want to do red. That's too orange. All right, and where's my y-intercept? 12. Y equals negative 12, so that's going to be 0, negative 12. All right, positive versus negative. I'm going to get my highlighter out. Do we agree there's actually like two separate pieces that are in the positives? You see that? And then I got one piece that dips under to get negative values. Okay, so parabolas are special that way. They're going to have two pieces doing one thing and one piece doing something else. Okay. So it looks like on the right side of 3 and on the left side of negative 4, would you agree that those are my positive pieces? Does that make sense? Talk to me or nod. So we're positive when x is on the left side of negative 4, left, less, right, 2 L's. And then we're also positive when we are greater than 3. Greater and right have an R. So on the left of negative 4 and to the right of 3, we have positive pieces. Okay? So we haven't really said in between yet, because the part that's negative, see how it's dipping in between two x values? So these x's are in between negative 4 and 3. So we write it, we are negative when our x values are in between negative 4 and 3. Your symbols will always go that direction because you always do smallest to greatest when we list it, left to right. So your alligator will always eat the right side because it's bigger. So see how my x is actually in between two numbers when I wrote it? And the part that dipped was actually in between two pieces. So make your math make sense. All right, my next one, is it still a parabola? My next example, is it still a parabola like the one we just did? Does it have a curve? Yeah, but how is it just a little tad bit different? It's upside down, okay? So let's just see what that does. Do we still have x-intercepts? Yep, where's it happening? 1 and 4, okay? So when x equals 1 and 4, you could also say 1, 0, and 4, 0, like that. So again, we can kind of go ahead and be like, okay, I know these numbers are going to be used when I get down here, right? You know that's going to happen. 1 and 4 is what we're going to use when we talk about positive, negative. Do we have a y-intercept? Yeah, where is it at? 1, 2, 3, negative 4, yep. There we go. All right, ready for positive and negative? Okay. So where are we positive this time? When we're above the x-axis. So now it's that little turn that's above it. So we're in between what two values? Looks like we're in between 1 and 4. Yes, no, maybe, you with me? We're in between 1 and 4. So we're positive when x is literally in between 1 and 4. All right, and we're going to be negative. Looks like I have two pieces now. We have two pieces that have negative y values. So it looks like this is to the left of which x-intercept? The 1 or the 4? The 1. And my other negative piece is to the right. I'm going to point to the right of what x value? 1 or 4? 4, thank you. So we're negative on the left of 1 and to the right of 4. Is it kind of clicking? Does your math make sense? Okay. Okay, going to the back. So now what we're doing on the back is we're giving these numbers context. Okay, we're giving them meaning. So the graph shows the height of a ball for each second x that is airborne. Use the graph to estimate the x and y intercepts of the function, where the function is positive and negative, and interpret the meanings in the context of the situation. All right, so let's do our x-intercept first. So I'm going to zoom in so we can see this graph a little bit better. Where is our x-intercept going to be? Looks like about 9. Okay, so when x equals 9. What does that mean with context? So what does your x represent in this graph? Is it time or is it height? It's time, right? It takes 9, seconds for what to happen to this ball? To hit the ground. And I know it's the ground because remember it's 9 seconds, 0 for my height. It didn't go anywhere. So that's when it hit back down on the ground. It's not in the air, up in the air anymore. All right, do we have a y-intercept? Yes, where is it? 4. So where y equals 4, which is also 0, 4. How can I interpret that? So if 0 is my seconds and 4 is my feet, what does that mean? Four feet with no seconds, so have they thrown the ball yet? No, so that's where the ball is being thrown. Okay, your y-intercept is always where something starts. Okay, time is 0, nothing's happened yet. So this is the initial height of the ball, our starting height of the ball. Initial height of ball is 4 feet. So you can kind of picture that, right? If I throw a ball, I'm not throwing it from the ground, right? I wouldn't throw it from about right here. That would make sense. It's about 4 feet or so off the ground. Okay, so someone's throwing the ball. All right, when are we positive? It's almost a trick question. When are we above the x-axis? The whole time, right? So we are always positive. When I'm going to say all... Well, that's not true. That's not true. It's not all of them. It's when x is greater than 0, technically. Okay. I don't like that either. Because it's not going to go forever. It's going to be in between 0 and 9, right? Because we threw the ball at 0 seconds. The ball hits the ground at 9 seconds. It ain't going to go anywhere else. Yeah, in between 0 and 9. There we go. Thanks for staying with me. Yeah, the whole thing is positive, which means the whole throw is in positive. And the throw only lasts between 0 and 9 seconds. Okay? When are we negative? Are we ever underneath the x-axis? No, it's never happening. Under the x-axis would show negative height. Is our ball going underground? No. So for this problem, that does not make sense. It would not make sense to have negative y values. The ball is not going under the ground. Might be. Well, it gets up to 9 feet, though. If you're ever dealing with water, is it possible to go under the water? Yeah, so those real-world situations, a negative y value would be okay. All right, but here we're like throwing it outside on the ground. It's not going to go under the ground. Gravity doesn't change, though. If you throw something, gravity's going to bring it down the same way. Yeah? Another one? Okay. Here we go. Now we have a table. All right, lunch. Violet starts the semester with $150 in her student lunch account. Each day she spends $3.75 on lunch. So we can see that happening on the Y scale over here. The table shows the function relating to the amounts of money remaining in her lunch account to the number of days Violet has purchased lunch. All right. Do we have an x-intercept? Yes. So remember, x-intercepts is when we have a y of 0, right? So do we see that happening on my table? Do I see a y value of 0? Yes. What x value matches with it? $40. Yeah, this part right here is showing your x-intercept. So what does that mean? Remember, x is time, y was money. So what does this x-intercept show about her money and stuff? How many days does this represent? 40 days, how much money? 0. So it took her how long to empty her account? 40 days. So, has no money after 40 days. So she can buy 40 lunches with her $150. All right, how about my y-intercepts? So remember, y-intercepts are when our x is 0. So where is that happening? 0 and the 150. Good. Again, that x is y. I mean, the x is time. The y is money. What does this represent? She hasn't bought a lunch. And she has $150. Good. So this was the starting amount. Starting amount of $150. Good. Y-intercepts, bless you, is always where we start. Y-intercepts is always where you start with something. I start with this much money. I start at this height before I jump off the diving board. I start here. Okay, y-intercept is always where you start. Let's do one more table. All right, movies. Ashley received a gift card to the movie theater for her birthday. The table shows the amount of money remaining on her gift card, Y, after X trips to the movie theater. Find the y-intercept. If we're finding the y-intercept, do I want my x to be 0 or my y to be 0? I want my x to be 0. Good. So it's going to be 0 something. What is it? 0, 90. Good. Our y-intercept has an x value of 0. It didn't tell me to interpret that, but I'm going to ask you to interpret that. So if y-intercept is where I start, what does the 90 mean? Starting with 90 what? Dollars. There's $90 on her gift card. Is what that shows. All right, part B wants you to find the x-intercept, and then we are going to interpret that one. So x-intercept, is that when my x or y is 0? It's when my y is 0. So where do we see that happening? 10 and 0. Good. So when x equals 10. So what does that show with her gift card? Yeah, she got 10 trips. Good. Yeah, 10 trips, 10 uses, 10. Oh, yeah, it's trips. 10 trips to the movies with card. Yeah, so out of her $90, she got to go to the movies 10 times. How we feeling? Besides tired. Okay. Sleepy. Okay. This is a whole lot of words. I will read them to you. And the solution or a root of an equation is any value that makes the equation true. A 0 is an x-intercept of the graph of the function. The graph of the related function can be used to find the solutions of an equation. The related function is formed by solving the equation for 0 and then replacing y with f of x or y. Values for x, which f of x equals 0, are located at the x-intercepts of the graph of the function and are called zeros of the function. The roots of an equation are the same as the zeros of its related function. The solutions and roots of the equation are the same as the zeros and x-intercepts of the related function. That is a whole lot of words to tell you that these words all mean the same thing. Solutions, roots, zeros, and x-intercepts. Okay? It's 4 different ways to ask you for the exact same thing. Okay, so if you're ever asked to find the solution or the root of a function, that's the same thing as asking for a 0 or an x-intercept of the graph. It's the same thing. It just usually depends on like what is given to you. If I give you a graph, I'm going to ask you for the intercepts. Does that make sense? If I give you an equation, I'm going to ask for the solution, okay, or the root. So 4 different words that are asking you to do the exact same thing. Our next one gives me an equation and a graph. Okay, so it says solve negative 2x plus 7 equals 1 by using the graph of the related function and then check your solution. So the graph they gave me matches that equation. So if I were to take this equation, which we're going to in a minute, and actually like rearrange and get x by itself and solve for x, what should my answer be if this graph matches it? It should be x equals 3, right? It should be the same thing. We're going to check it. So if I have negative 2x plus 7 equals 1, and we solve for x, tell me what to do first. Oh, we're digging back. What do I move, the 2 or the 7? There you go. Subtract that 7. So I have negative 2x now equals, what's 1 minus 7? Negative 6, good. And then how am I going to move that negative 2? Divide both sides by negative 2. And what is negative 6 divided by negative 2? 3. Ooh, did they match? Yay. So when you were doing that earlier in chapter 1, you were essentially finding your x-intercepts without knowing you were doing it. So if you get a function and a graph, you have 2 ways to find x. We still feeling okay? What's up? Say it one more time. Yes, you're finding what x equals. Yep. And sometimes graphs can be deceiving, okay? Because graphs, they're great, but it's like, is that a 3 or is it like a 3.1? And sometimes it's hard to tell if it's exactly 3. So working out the equation, that was the purpose of that, to prove it. Like, yeah, that is exactly 3. All right, let's look at this guy. Find the solutions of the following graph. So it's nice when they have them kind of like plotted for you because you know they're going to be exact. So what are the solutions of this parabola? Where's it crossing the x-axis? At 1 and at 3. Is it when x is 1 or when y is 1? When x is 1, and is it when x is 3 or when y is 3? When x is 3. So you could also say 1, 0 and 3, 0, same thing. Okay, so pulling from a graph is nice. All right. Questions about intercepts or positive and negative? We will practice with this tomorrow. Okay, keep it out. Let's stamp.